Welcome to this video on data visualization with Tableau Public. In this exercise, we will be using Tableau Public to explore data from the Social Security Administration that you loaded in the Intro to Tableau Public video. At the end of the exercise, you'll have created and published an animated visualization that will allow anyone to find when their name peaked, at least in the United States. If you have not watched the intro video and loaded the dataset, please do that first and then come back to this exercise. When creating a visualization, it's important to first decide if the goal is exploratory or explanatory. For exploratory visualizations, you should always start with a question, possibly a bit fuzzy at first and evolving as you go. But if you don't start with a question, it's really easy to end up going down a rabbit hole as you find interesting things in the data. In the process of creating visualizations, you may learn more about your data, but you also may learn more about the question you are trying to solve. Depending on what you find, the exploratory visualizations may evolve into explanatory visualizations. For example, if you are trying to figure out why are sales down or why are customer reviews trending negative, that may lead to an explanatory visualization that you present to management. For explanatory visualizations, you will be communicating the answer to a problem. For example, you may have done the exploratory visualizations and found out why sales have decreased. Now you need to communicate the findings to others using a story format. What's the problem? What does the data tell us? And what should we do about it? It is important to keep the context in mind. Who is the audience? Also, will your presentation be narrated or does it need to stand alone? If you have not watched the video snippet with Hans Rosling, please do so. In 6 minutes, you will see how a well-told visualization story can shatter preconceived notions that people have held for decades. In this exercise, we will focus more on exploratory visualizations. In addition to explanatory visualizations using a storytelling approach, each type of chart is best at communicating the data story for a specific type of question. Before you start building a visualization, you need to decide which story matches up with your question. If you have not read pages 5 through 13 of the Visual Analysis Best Practices, please do so. It's mostly pictures, so more viewing than reading. Although there are other publications that will show you more charts, the really beautiful thing about this guide is that it starts with the data stories shown here, and then matches charts to the type of data stories they tell. We will refer back to this slide, but it covers 5 basic types of stories. There are trends, comparisons, distributions, correlations, and part of a whole. Before we dive into the data, a couple key concepts to keep in mind. If you are doing a line chart, the x-axis should be something continuous that has a direction, such as time. If you ever find yourself doing a line chart and putting cities or offices on the x-axis, don't do it. That is matching the wrong chart with your story. Similarly, bar charts are for counting. You should never use a bar chart to show an average. If you feel an overwhelming urge to do so, look up how to do a lollipop chart. Instead of just an average, you should use visualizations that tell the whole distribution, such as a box plot or histogram. But you need to first make sure your intended audience will understand them. In Hans Rosling's presentation, he used the bubble chart, and that's similar to a scatter plot. These are perfect for showing a correlation, such as he was showing life expectancy at birth versus average family size in countries around the world. If you are creating a scatter plot, both the x-axis and the y-axis, in Tableau that would be the row and column shelf, must be continuous data. If you have cities or offices on the x-axis, what you're really doing is just creating a box plot with most of the information stripped out. The last story type is part of whole. The pie chart is a chart type most people are familiar with. As a rule, don't do pie charts. Researchers have found that, well, pie charts stink. A better choice is the 100% stacked bar, where the y-axis goes from 0 to 100%. Although the name is similar to the bar chart, A 100% stacked bar chart tells an entirely different story. Let's dive in. You loaded the data previously in the Intro to Using Tableau Public video. If Tableau Public is still open on your computer, that's great. If not, double-click on the Tableau Public icon on your desktop. When Tableau appears, there should be a tile on the screen for the Exploring Names workbook that you previously created. The tile will be blank and sort of boring, but that's because you have not created any charts yet, but you will soon. Click on that tile to reopen the workbook. If instead you are using the web-based version of Tableau Public because you're on a lab computer, use the link in Canvas to go to the URL shown here and then log in as you've previously done. Your primary visualization question in this exercise is when was peak U, meaning was there a period when your name was most popular? Keep in mind that the data from the Social Security Administration is based on people born in the US. So it's not a perfect data set in the sense that, well, it excludes most of the world's population. First, there may be some preliminary questions we should ask. The first question we want to look at is whether we have good data for both men and women. The count field in the data contains the number of people with a specific name in a specific state for a specific year for a specific gender. Drag the count measure to the row shelf. Tableau will automatically decide that sum is the aggregation to apply to this measure, which is what we wanted. The sum will be the total Social Security applicants from 1910 through last year. Tableau guessed that you wanted a bar chart, which is a good chart for telling a story about a sum. If you hover over the bar, you will see it's over 300 million people. Since we want to know if we have sufficient data for men and women, drag the gender field onto the column shelf. Although we have more data for men, both genders have a substantial amount of data. Although we could add color for the gender, we should not gratuitously add colors to our chart. However, it would be good to have better labels. Currently, our bars are labeled F and M. To change the labels for the gender values, click on the drop-down arrow for the gender dimension in the data pane and select Aliases. In the pop-up dialog that appears, the first column shows the values in the data. We can enter an alias for each value in the column on the right. Click on the alias column and set F to women and M to men. Click the OK button to save your changes. The Y-axis label could be better too. Double-click on the Y-axis. In the dialog that appears, change the axis title to be Social Security Applicants. Although it may seem odd, there is not an OK or Done button on this dialog. Click the X in the upper right-hand corner to close the dialog. One last change we need to make is the title of your chart. You may have noticed that the tab at the bottom and the name of the chart are both Sheet 1. This screams amateur night. Click on the tab for Sheet 1 and change it to Total Men and Women. If you click away from the tab, it will automatically update the chart title. Although this chart addresses our first question about having enough data for both men and women, since the main question is about finding peak U, we should look at this by year. Let's keep this chart but build on it. Right-click on the tab for the chart and select Duplicate. Tableau created a duplicate tab. Let's rename this one Men and Women by Year. Instead of gender on the x-axis, we want to see the year, so drag the gender field off of the column shelf. Now, drag the SSA year dimension onto the column shelf. Tableau automatically figured out that we are now showing a trend and switched to a line chart. The x-axis label would be better as just year, so double-click on the x-axis and change the title to year as you did previously for the y-axis. Our chart now shows a trend over time, and we can clearly see why the boomers are called the baby boom generation. However, our line chart is combining men and women as a single line. Keep in mind that each dot in that line is made up of the rows in our data, so the peak in our chart in 1957 is based on the sum of the data points for all names and all states for both genders. Drag the gender field onto the color shelf in the marks card. You now have separate lines for men and women, and by chance, Tableau even picked SGSU colors. At the end of this exercise, when you publish your work on Tableau Public, you may want to explore further. Here's a few ideas you could look at. However, at this point, we'll pivot to working on our main question, finding peak U. First, you may want to save your workbook at this point. When starting a visualization, it's always a good idea to sketch out what you plan to do. In the book, Thinking with Data, Max Schron refers to this as a vision. These are low-fidelity sketches, often using pen and paper, sort of a back-of-the-napkin type of mock-up. Doing this up front has some tangible benefits. First, it creates a visualization of what a successful outcome could be, and provides something you can share with others in order to get feedback. It can also help identify errors in your thinking and issues that you may not have thought of. However, since you have not spent much time creating it, you're not overly committed to it and would be willing to modify it in response to the feedback you get. The vision we'll be working with is that we want to show the popularity of a name. The darker the color, the more popular the name. We plan to animate this so it shows the change from year to year. The pie charts will show the percentage of people in that state with that name in that year who are male or female. Also, as in a visualization done by Hans Rosling, the size of the pie chart will indicate the number of people with that name in that state for that year. Let's get started. To start a new visualization, click on the tab for a new worksheet. That's the tab immediately after the last chart you created. The state code field is a spatial dimension, so to start your map, drag the pill for that field to the column shelf. Initially, the view will just contain a line with the state codes in alphabetical order. Tableau includes the Show Me palette, which has a selection of common chart types. If the palette is not already displayed, click the Show Me tab. You will see two map icons. The one that's highlighted is a symbol map, which unfortunately is not the one we want. The symbol map is really useful if your data already contains latitude and longitude coordinates. Although Tableau has generated latitude and longitude measures based on our geographic fields, in our case, the coordinates would always be in the center of the state. Instead, select the map option. This creates what is known as a choropleth map, meaning it'll fill in the geographic boundaries for the states. After you select the map option, Tableau will move the generated latitude and longitude to the row and column shelves and move the state code field to the detail shelf. You may be thinking the row and column shelves would not matter in this case, but they do. Keep in mind that the latitude are the horizontal lines on the globe, like rows in a table, and the longitude is the vertical lines on the globe, like columns in a table. By using the Show Me palette, Tableau takes care of remembering all of that for us. Now that we're done with the Show Me palette, click on it again so it's not blocking the view. The map will initially be sized so all of the states are visible. This includes Alaska, which takes up a lot of screen real estate. If you hover your mouse over the map, you'll see a toolbar that's there for working with the map. Click on the arrow at the bottom of that toolbar, and then click on the icon with the arrows. This is known as the pan control. It allows you to move the map with your mouse. Center the United States in the middle of the view. Click on the plus symbol on the toolbar to zoom in until the lower 48 states fill most of the view. Currently, your map looks rather boring because there's a lot of data in each state. You loaded over 6 million rows of data, so each state is filled with the rows for that state for every name, for both genders, for every year from 1910 to the present. You want to find the year a name peaked in popularity, so you need to filter the map to contain only the name you currently want to look at. To do this, drag the name dimension onto the filter shelf. A dialog will appear that lets you specify the filter. You don't want to filter for just your own name, so select the Wildcard tab. On this tab, you can specify the value you want to match. For now, enter Linda, even if your name's not Linda. Trust me on this. You can also specify how you want to match. Select Exactly Matches. Although you may be tempted to select Contains, a lot of nicknames are not a substring of the name, such as Jack is a nickname for John. Also, a lot of names contain other names, such as Roberta contains Rob, but Roberta is usually a woman's name, and Rob is usually a man's name. If a name contains no data, then it should show an empty map, so uncheck the option to include all of the data when empty. Click the OK button in the dialog to save the filter settings. Currently, the filter only works for the name Linda. What you need to do is show the filter on the visualization so anyone can change it. Hover your mouse over the name pill on the filter shelf and click on a drop-down arrow that appears. From that menu, select Show Filter. This adds an input box on the right side of your visualization where users can enter any name. For now, leave it set to Linda. Since we want to be able to see what year a name reached sort of its peak popularity, we want to animate the visualization by year. Drag the SSA Year field to the Pages shelf. This will add animation controls to the right side of the visualization, just under your name filter. These controls will allow you to play the animation to run from 1910 through last year. You may have also noticed that Tableau automatically added the year to the title of your chart. Currently, the animation is a bit boring. It shows whether there are any records for the selected name in each year. What we really want, as shown here, is to reflect how popular a name is relative to other names. To do this, we need to be able to calculate how many people had a given name by state by year. So in the example shown here, how many people named Linda, girls or boys, were born in Utah in 1942. However, we don't just want to compare that to the total births in Utah for 1942. Even if a name was really popular, it would not be 100% of the children born that year. That would be really freaky. Instead, we want to know how does the total for a particular name compare to the most popular name in that state for that year. To be able to do this, we need to create some calculated fields for the following. First, the total births in each state by name by year. We then need to know from that which one's the total for the most popular name in each state for each year. Taking those two numbers, we can say what's the ratio for the selected name total compared to the most popular name total. This will give us a ratio for the popularity. The most popular name in a state would then have a ratio of 1. First, we need to create a calculation for the total for each name by state by year. We will call this field Annual Name State Total. To create a calculated field, select Analysis from the Tableau menu at the top of the screen. From the drop-down menu that appears, select Create Calculated Field. It's near the bottom of the menu. A pop-up dialog will appear where you define the calculation. The initial name of the field will be Calculation 1. Change that to Annual Name State Total. Since we want this calculation to always be by name, state, and year, we'll create what's known as a fixed level of detail, or LOD calculation. This means that no matter what other fields or filters we use in a visualization, it'll always be calculated at that level, the name, the state, and the year. All LOD calculation fields are enclosed in curly braces, so we start with those. We'll only be using the fixed level of detail, so that's added at the start of the calculation. As we begin to type, you'll see that there's a pop-up menu that we can select from. Next, we need to tell Tableau the context for the calculation, which is the level we want it calculated at. So we select the state code, SSA year, and name fields. As you start typing a field name, you can select it from a list. The order of the three names does not matter, but be sure to put a comma between the field names. Next, we need to add a colon to separate the context from what we're aggregating. Following the colon, we need to add our formula for what we want to aggregate, which is, by name, state, and year, is the sum of the count field. Be sure to add the parenthesis to close off your formula for the sum. Also, if you didn't add it at the start, be sure to add the curly brace to close off your formula. This completes the formula. And now in the lower left-hand corner of the dialog, it should say that the calculation is valid. So click the OK button to save the formula. Your calculated field will now be listed in the Measures section of the data pane. The only real indication it's a calculated field is there's a really small equal sign in the front of the data type symbol. Now let's add the other two calculated fields that we need. Now that we have calculated the total for each name by state by year, we need to determine the total for the name with the highest total within each state and year. To add another calculated field, select Analysis from the Tableau menu again, and select Create Calculated Field from the drop-down menu that appears. Enter the name for the calculation. This time we'll call it Max State Annual Total. Enter the formula for the calculation. The context is similar to the prior calculation, except this time it does not include the name, since we want to calculate across all the names within a state for a year. The aggregation calculation should get the maximum total we just calculated within that state and year. As you did before, check that the calculation is valid, and then click the OK button. The last calculation we need is a ratio between the name being filtered and the maximum name. This ratio will indicate the popularity of the name. The most popular name in the state and year will have a ratio of 1. Since the Pages shelf has already determined the year we're visualizing, and the Filter shelf has determined the name we're visualizing, and the state code on the Detail shelf and the Marks card has determined the state, this calculation does not need to be a fixed level of detail calculation and is instead much simpler. As you did before, select Analysis from the Tableau menu again, and select Create Calculated Field from the drop-down menu. Enter the name for the calculation. We'll call it Popularity. The calculation itself is just the annual name state total divided by the max state annual total. As you did before, check that the calculation is valid, and then click the OK button. With the name filter still set to Linda, drag the new popularity measure onto the color shelf and the Marks card. Since Tableau will aggregate measures by default, we need to turn off the aggregation of measures. Click on the Analysis option in the Tableau menu. From the drop-down menu that appears, uncheck the Aggregate Measures option that appears near the top of the menu. On the right-hand side, you'll now see that there's a key for the color coding of the popularity field. By default, the color will be a continuous, graduated color without discrete steps, which makes it a bit difficult to differentiate the popularity of a name in different states unless there's a really dramatic difference. Most likely the color selected is rather bland, so even the most popular name would not look red hot. You may also have noticed that the lowest value on the scale is not 0. This could vary for different names, since it would be tied to the lowest value for that name in any state for that year. It would be better to have the scale be from 0 to 1. For the color coding, we want the most popular name to be red hot. Click on the drop-down menu on the title of the popularity color legend and select Edit Colors. This will display a dialog that allows you to adjust the color scheme being used. In that dialog, from the drop-down list for the palette, select Red. It will still be a continuous range, which makes it a bit difficult to differentiate the popularity in different states. Below the palette, check the box labeled Stepped Color. This will default to 5 steps. Increase the number of steps to 10. The last change we want to make to the color palette is that the maximum red is not red hot. Click on the square to the right of the Step Color palette and select a deeper red. We have one more change to make to the color legend. We always want the scale for the popularity to go from 0 to 1. Click the Advance button to show additional options for the color legend. Check the box for the Start option and set the start value to 0. Check the box for the End option and set it to 1. Click the OK button to save your changes. Make sure Linda is still selected in the name filter. Click the Play button and wait. When you get to 1947, Linda as a name becomes red hot. In fact, it is the biggest spike in trendy names of all time, at least since 1880 in the United States. The reason is a song named Linda that was written by Jack Lawrence and released in 1946. The song was written about a 1-year-old Linda Eastman, who was the daughter of his attorney at the time. Later in life, she became Linda McCartney, the wife of the Beatle, Paul McCartney. There are still a few cosmetic issues that we need to clean up in this visualization. On the animation controls, select the drop-down menu, then select the Edit Title option. Change the title to be the year instead of SSA year. Edit the name on the tab of the sheet to set it to Name Popularity. The chart title automatically picks up the name of the chart and the year page, but it would be good to include the name being shown in the animation too. Hover your mouse over the title of the chart, and you'll see a drop-down arrow on the right-hand side of the title. Click on that drop-down list and select Edit Title. You'll see that the current title is Sheet Name-Page Name with both of the name fields in angle brackets. The angle brackets are for formulas that allow the title to pull in the name you just entered on the tab, which is the sheet name, and the year, which is a page name, since you put the SSA year field in the pages shelf. Edit the formula to include the name and angle brackets between the sheet name and the page name. Click the OK button to save your changes. Now that your visualization looks more professional, be sure to save your work. Now that you have saved your work, be sure to publish it to your Tableau Public account. From the Tableau main menu, select the File option, and then select Save to Tableau Public. You may be prompted to sign in to Tableau Public. Be sure to use the email address and password you used when creating your Tableau Public account. Depending on your internet connection, it may take a few minutes to upload the data, but then your visualization will open in your browser and be displayed in your Tableau Public profile. For the assignment in Canvas, you'll be sharing the link to your visualization on Tableau Public. On the visualization, click the sharing icon. It looks a little bit like a wishbone. A dialog will appear that offers an embedded link, which you could use if you're embedding it on a web page. Instead, click on the Copy Link button to get the URL. Submit that URL for the assignment. You now have a published animation that you can use to find the year where your name was most popular. However, at the start of this project, we identified 2 features that it would be nice to include: the breakdown of gender and the size of the relevant population. We could add a pie chart to our map for each state to show the gender breakdown, and the size of the pie chart could reflect the population. To do this, we need to create a dual-axis chart. Generally, if you've heard about these before, you would think of a dual-axis chart as having a y-axis on the left side and a second y-axis on the right side of the chart. When doing a map visualization, the second axis is instead an overlay of the map. Let's try it out. First, since you have a working visualization, let's not mess with it. Right-click on the tab for the name Popularity sheet and select Duplicate. Let's rename this copy Name Popularity with Gender. The first step is to create the other axis for the chart. Drag a second generated latitude measure onto the row shelf. You now have two copies of that field on the row shelf, and Tableau has generated a second copy of the map that's now below the original map. Initially, both maps look the same, but you may have noticed that Tableau has now added a separate marks card for the second map. The marks card now has three options. Whichever of the three options is bolded is the marks card that's active. Any changes to the marks card named All will apply to both maps, but each of the maps also has its own marks card. We want the marks on the second map to be pie charts, so select the marks card for the second map. In the drop-down list for that marks card, change the type of mark from map to pie. Initially, the pies on the second chart are a uniform size and the same shade of red as the corresponding state in the original map. Let's add gender to the pie charts. With the marks card selected for the second map, the one with the pie charts, drag the gender field onto the color shelf. Tableau automatically adds a key for the gender below the animation controls on the right-hand side of the visualization. If you're not satisfied with the color selected, hopefully you like blue and gold, click on the color shelf to edit the colors. The size of the pie chart will be used to reflect the size of the population for that name in that state in that year. Make sure the marks card for the map with the pie charts is selected. Then, drag the count measure onto the size shelf on the marks card. Tableau added a key for the size of the pie charts on the right-hand side of the visualization. We don't really need this key displayed, so click on a drop-down list for the title of that key, then select the Hide Card option so it won't be displayed. Initially, the pies will be small. With Linda set to 1947, click on the size shelf and adjust the slider to increase the size of the pie charts. Keep in mind that Linda in 1947 is likely to be the maximum size for the pie charts, since Linda in that year was the most popular name we've seen so far. This completes adding the two features that we said it would be nice to have. To combine the map so that the pie charts from the second map overlay the original map, select the drop-down list for the second latitude field on a row shelf and select the dual axis option. Now that you have completed the enhanced version of your visualization, be sure to save it. Also, be sure to save the improved chart to Tableau Public. To test your gender feature, try one or more of the names listed here.